Well, in problem number 1, we're given information about a particle that's moving along the x-axis. The particle's velocity function is provided, and the particle's acceleration function is provided. The position function for the particle is not given to us, but the initial position is. At time t equals 0, this particle is at 2 on the x-axis. In part A, we're asked to determine if this particle is speeding up or slowing down at time t equals 5.5. Now, what we're going to do is we're going to look at the velocity at time t equals 5.5 and the acceleration at time t equals 5.5. And comparing the sign of these two values will tell us if the particle is speeding up or slowing down. If the sign of these values are the same, then our particle is speeding up, and if the signs of these values are different, then our particle is slowing down. Now, this is a calculator question, so you're allowed to use your calculator. If we evaluate the velocity function at time t is 5.5 seconds, we'll get something approximately negative 0.453. And if we evaluate the acceleration function at 5.5, we'll get something approximately negative 1.359. Now, since both values are negative, we can conclude that the particle is speeding up, or that the speed is increasing. Now we're supposed to give a reason for this. We should be more specific. The speed is increasing at time t equals 5.5. Now we'll give a reason. Because v of 5.5 and a of 5.5 have the same sign. They're both negative. Okay, that's it for part A. Now moving on to part B. For part B, we're asked to find the average velocity. So to find the average velocity, what we can do is we can find the average value of the velocity function over the time interval from 0 to 6 seconds. So we can integrate from 0 to 6 the velocity, and then, of course, we'll multiply by 1 over 6 minus 0 to get the average value. So let's see here. This is going to be 1/6 times the integral from 0 to 6 of, 2 times the sine of e to the t over 4, which we're going to call 1/4 t, plus 1. And this whole integrand, of course, is being integrated with respect to t. Again, this is a calculator question. We are allowed to use a calculator. So if you type this in your calculator, we'll get that the average is approximately 1.949. Now we have to be careful here. If they give us units, we should include units in the answer. Well, they don't give us units. Matter of fact, they don't even give us units for time. I think we assumed it was seconds. Since they don't give us units, we cannot include units in our answer. So the average velocity on a time interval from 0 to 6, whether it's seconds, minutes, hours, days, years, whatever, is about 1.949 units per unit of time. And that's something for part B. Now let's take a look at part C. In part C, we have to find the total distance traveled. So for this, we have to remember that if you integrate from 0 to 6, the velocity function, that'll give us displacement. But if we integrate the absolute value of velocity, we'll get total distance. So again, this is a calculator question, so we can type this into our calculator, and we'll get about 12.573. We don't know what the units are, so we'll just leave our numerical answer alone. Now finally, in part D, they tell us that the particle changes direction exactly once. Find the position of the particle at that time. So we have some work to do here. So to do this, part of the problem. We're going to make a sign chart for the velocity, and we're going to find the critical numbers. We're going to find wherever the velocity is 0 or undefined. The velocity is 0 exactly one time on the interval from 0 to 6, and the velocity is undefined never. So here's what we're looking at. And again, we're using our calculator. We're going to find that the velocity is positive for the first part of this interval and negative for the second part of this interval. And now let's see what the question was asking. They were asking us to find the position of this function, or this particle, at the time when it changed directions. So we changed directions at about 5.196. Now, of course, we have more decimals of accuracy on our calculator. We use more decimals of accuracy when calculating answers, but we're going to write 3 decimal places on our paper. So now to find its position, we have to remember something very important. This is what a lot of students forget. We have to remember that the initial position at time t equals 0 was 2 on the x-axis. So coming back here, we know that the position at time 5.196 is going to be about 2, the initial position, plus now the displacement from 0 to 5.196 of the velocity function. So what we're going to do is we're going to go to our calculator and we're going to type in 2 plus the integral from 0 to 5.19552 to get a few more decimal places of accuracy of the velocity function, which is, 2 times the sine of e to the 1/4 t plus 1. And of course, we're going to integrate all of this with respect to t. I'm trying to make this look a little clearer for you to see. There we go. And if we type this into our calculator, we're going to see that x of 5.196 approximately, the bug's position at the time that it changes direction, and not the bug, the particle, is going to be approximately 14.135. Again, we don't know what the units are, so we just know that when the bug turns around, its position is approximately 14.135 on the x-axis. I hope this was helpful. Thank you for watching the video.